Good evening to you all again for another time. The recording of this presentation will be on the YouTube, right? So I'll be posting this very seminar number 2 on YouTube as well in my channel that includes or that collects all the video presentations of mine, including the class presentation and also the test specimen presentation. And for today, which is such a quiet day, the thing is that we had the situation in Thailand today that the explosion at the petrochemical factory was in the early morning today at 3 a.m. and that is still ongoing. The flame is still not put down yet, so we have to still people are still worrying about this issue, which is still ongoing, and it is quite dangerous because the explosion occurred already once in the early morning, and that affects many houses around there and the factory around there from the pressure of the explosion. So it is very quiet in Thailand for this evening, that people are very busy moving moving the people to the safe place, because the smoke is also a concern. Yeah, it is very toxic, and that could be the problem to the health. All right, but we are focusing today on the events that actually occur over about a week already in Florida, and this is in the United States of America. Yes, as Florida suggests, it is the state in the USA. Right, so this banner I post it here such that we can read while you are waiting, and I put here around 1:30 a.m. in the morning. That is the local time, which is the Eastern District time. June 24th, the beachfront wing of the condominium. It is the wing that is just right in front of the beach. You will see the plan of this structure in a bit, and it collapsed and caused more than a dozen of casualties. A dozen of casualties that I mentioned there was actually the confirmed cases of casualty. The thing was that there are so many people, at least around 140, 150. Yeah, people are in here. It is, yeah, 140, 150 people which are unaccounted for. So the status is unknown. We do not know what's going on with them, but now it has been a week already under the rubbles, right? So a dozen, actually up to today, it's not just a dozen, it is already 2 dozen already. They found 20 something casualties. The latest update of today I haven't checked, but the number is around that 24, 25 plus already that they can find from the rubbles. And yeah, over 100. That's July 1st. That was the time that I prepared the presentation, or basically this page, not the entire presentation. This building is 12-story in height, and add up with the penthouse unit at the top. So in some zone, you can count it to 13-story. And the video footage shows us quite clearly that the collapse starts from the lower floors, lower story. It settled down and suddenly one part of the building, which is the middle part, comes down all the way to the ground, and then the beach front side part also comes out later. So let me just give you some idea. So we are talking about this disaster which is in the USA, and to be specific, we are talking about Florida, and this part here is the south of Florida. To be more specific, it is in Miami. So I point the arrow over here, and in Miami I give you further zoom in. So well, Orlando is here. Orlando is where you can go for the Disney Park and Universal Studio if you like this sort of activity. So Orlando is here, and West Palm Beach, blah blah blah. Miami is here. Tampa, which is quite a big city, is here as well. Jacksonville is there. I used to drive from Florida, but I don't remember exactly from where exactly in Florida, all the way back to Austin. So that was a very long distance driving of my life, which was somewhere around 18 hours straight. I just had like the break when I ate my meals, and then keep driving. So yeah, 18 hours straight from the starting to the ending at my apartment in Austin, the longest drive, and which is my record. Down here it is the Key West. Key West is the southmost part of the USA if you consider this east side. I'm not so sure if we consider this part. Well, yeah, it is lower than Houston, this bottommost part of Houston. So then Key West is the southmost part of the USA. Yeah, it is a point of interest. If you visit Florida, this is the must that you have to come all the way down to Key West. Well, nothing there basically, but just the milestone. And well, zoom further into Miami. This the city of Surfside. You can see that this is the land which is uh, outside the mainland. It is coming into the ocean, and generally the part over here will be experiencing the hurricane quite very often, because Florida is the state that get hit by the hurricane very easily. So the hurricane comes from here, sometimes from the Gulf of Mexico, come up to Louisiana or Texas, Houston, and sometimes it comes all the way here and then hit Florida. So this is a city that people are very good at handling the hurricane. But what's going on in here is not about hurricane. Now I showed you this picture a little bit such that you get the idea about Miami Beach. Very nice picture that I took in 2005 or 2006. How many years ago? Yeah, somewhere around 15 years ago, right? Yeah, around that long I had that trip, and yeah, this is the beach on Miami. Well, you go there, you don't expect a good seafood. Seafood in Thailand is generally better. There's no real fisherman there, because when you go to the restaurant, they're gonna get like the shrimp that is imported from Thailand and fry fish. Well, so don't expect too much for seafood there. Well, the nice beach and a lot of old people there, retired people, come to this very nice and easy city. Uh, well, it's a good city for relaxing and for chilling out. And the building that we are talking about locates in somewhere around here of the surf side. So let's get further more. Now I zoom in a little further. You can see that this is a very nice city planning. The bay looks very good. This is the bridge for the yacht. Here is the building of our interest, exactly over here. The name of this building is the Champlain Tower South, because there are many Champlain Tower. There are Champlain Tower North, East, and South. The two other towers are the sister tower of this one. They are just on the northern side of this one, just a little bit, not far away from this one. I draw the frame over here such that you can see, we can focus on this very building. And what happened was that this wing, which is the beach front wing, collapsed all the way down. So it is a partial collapse, leaving just, leaving just this left part. This is the sea, the beach is on the west side. The east side, and the left is your west side. The north is up, the south is down. So, well, this is a very nice looking city. I give you more information a little bit. There's a CCTV camera installed over here, and the view, the angle of view of the camera is just pointing towards the Champlain Tower South. So this is the only video footage during the collapse, the only one video footage available around that vicinity. We have some other video footage to show you, but nothing is as good as this one, because it is not right exactly at the collapse moment. So we take a look at the building before the events a little bit. The picture, the view that I just showed you was taken at 88th Street at Collins Avenue. So it is around here at the traffic lights, and looking into the building. So you are looking at to this corner and the front of the building. Very nice. You can see the cantilever slab like this coming out. The building is old. The construction was in, well, almost 40 years ago. You have the car parking around this area. This is the entrance, so the cars just get in and get the parking. This is the front. There's another parking there, which is, well, you will see that later, and then you just drive down there. There's another entrance, Collins Avenue, and this is the 88th Avenue, 88th Street. And this part is the part that came down, and this part just came down today because people do have to take this piece down due to the hurricane that is coming in, and the stability of this remaining part is very questionable, so they take down this remaining side. What I'm talking about is this one. This is the entrance that you can get into the parking. So this will be showing in the video footage because something went wrong before the collapse. You can see some deterioration somewhere here, somewhere there, somewhere there. So the sign of deterioration shows not that seriously out here, because this is the outside. Well, the inside it shouldn't be as much as the outside, but the starting point of the collapse might not be shown around here in this picture, but you have some perception. Actually, in my view, for the building of which the age is very close to 40 years, this is just around the corner of 40, and the condition is so good like this. This is very well, this is still perfect in my view, if I can see from the outside, considering the age, which is about 40. And if I compare with many buildings in Thailand, 40 years is not at this condition. You can see worse, even worse deterioration. But anyhow, this one came down to the ground, so there must be something terribly wrong. But 40 years ago, well, I give you just some background. I could talk more about the background of this building a little later. You can see that the floor-to-floor height of the unit here is not as much as from this floor to this floor. All right. So this the slenderness ratio of the column in the ground, the first floor level, is more than the above floor. Now we look up, and well, yeah, we can see some deteriorations, but it looks like the cosmetic issue. Yes, you can say that the concrete, the rusting, the spalling out, the soffit of concrete is not just the architectural concern or issue, but it's still not making the very serious structural concern as far as you look from the outside of the building. Here is another view of the building. So right now we are looking from the nearby building that you're gonna see the collapse from this view as well. So previously I was on that street, and then I took many shots from that street. Now I'm on the opposite side, so you can see now the pool, right? And what this wing, well, I just look back to the Facebook, and I don't see the Facebook update the video, the live video, so I was worrying about what's going on in the Facebook. But I'll continue. If something goes wrong in Facebook, I'll post. I will probably post the YouTube video, so let's stick with that. Right. So let me just come back here, and the view that I just showed you. Here you see the swimming pool, right? And this is the side that we just saw. But previously I was at this intersection, and then I came down to here, so we can see the entrance here and there. Right now I am on the opposite side, so which is over here, right? And the unit that I circle in red is the unit where we had someone who escaped from the unit. Just thank you, Piti. Thanks a lot. Right. So we have a family that can escape out of this building just before the collapse. So well, we're gonna continue from this point, but let's take a look over here. You can see the column at the first floor. I just mentioned that it is more slender than the other floor. We have the ground, the basement level below here. All right, but this is quite slender compared to here. How do these people evacuate out of these units? This is the only unit out of this chunk who survive. Well, we have some other survivor who by chance just sleep at the girlfriend's house and not coming back home. something like that. Yeah, who is very, very lucky. Right, this is the penthouse unit that I mentioned, which is the 13th floor. This is the elevator shaft, around there, stair core elevator shaft. Right, this part survived the crash. The pool, the deck that you will see the pictures in a bit. Just give some more idea about how the pool side looks like, how this area looks like. So almost the entire footprint of this building, you're just gonna see the concrete slab. There are many levels. The floor slabs over here are quite so many levels, and it is tiling. Right, you see this tiling work everywhere. One thing, the tiling could traps the water, and that could lead to the long-term durability of the structure, because under the tiling work you will expect some spot. It is just the air gap that the construction worker might not just close it properly, and that traps the water. And if the water is there, that is the source of the moisture that come and attack to your steel reinforcement. This building, if it is constructed, I have seen quite many buildings in Thailand construct just right next to the beach, and the condition is horrible. I didn't have time to include those pictures in this very presentation, but it is really horrible. You will see the steel reinforcement exposed. You will see that it gets cut off by the saline water because of the iron, chloride ion that attacks the steel and rusts the steel out. You will see worse 20 years much worse than this 40-year structure. So this tells us something about at least the quality of the construction, like the covering of the steel reinforcement is quite good, such that you don't see the really bad corrosion in this structure. Anyway, well, it came down. So this piece of the structure, this is from where? USA Today. Okay, I need to cite them, to give a credit to them, because I borrowed the picture. Just circle the area where the collapse was. So let's just look at the event timeline. 1979. The development of the architectural drawing and engineering drawing is complete. So the bidding, the construction was after 1979. But think about 1979. It was what, about 41 years, 42 years probably already, right? So the design of the structure and this issue, the reason why they have this bad collapse, is also a part of the old codes of practice. 1981, the completion of the construction. So this building was opened 1981, but one thing, waterproofing was not included in this structure. I actually, it should be my job to just check further to see if the sister buildings are constructed before or after, or it is just the construction flaw. But those two buildings are still okay. They do not have severe rusting. They do not have the water leakage issue in the basement level like the Champlain South. But the thing that we know, the waterproofing for the underground level was not included. This is expensive thing, but it is mandatory. Without this, the longevity of the structure will reduce quite drastically. Now, October 2018, which is just 3 years ago, major structural damage warning was issued by the consultant. So the consultant issued this, and just a little later, in November, which is just the next month, well, the estimation by the consultant about on the cost that the residents need to pay for the repair was somewhere around 9 million US dollars. So if you multiply by 30 Thai baht per US dollar, that's quite a nightmare. Oh well, considering the cost of living in the USA that is higher than in Thailand, but still, yes, 9 million US dollars. So in total, there are 136 units in this building. So they have to share and pay for such big amount of money. And that's why the repair work is very slow and it's not happening. That's a part of the problem. Well, November month, just the very next month, a building official that, to my knowledge, this guy just quit already. From the town of Surfside, this person opened to the meeting with the Champlain Tower South Condominium Association. So they have the meeting, and he said something like the building is in very good shape. It is recorded in the minute of meeting. So they have one opinion, right? Sometimes you look for the second opinion. One said that you are not in good health, and another one said that you are very healthy. Well, now it is difficult because these are like very, well, one is on the moon and one is on the Mars, like totally different planet. And this person is from the authorities, right? From the town of Surfside. So, well, he has quite credibility for the people, of course. And the issue will be then like, oh, one said that it is bad, one said that it is very good. Probably they just add these two up and divide by 2. So they end up with the feeling like, well, it could be later. And yes, it could be later. That's why 2 years. Now, April 2021. The president of the condominium sent a letter to the residents. The thing is that the next year, they have to renew some sort of permit such that the how to say? Let me get a sip. I think I just received a bad news about the quota of the vaccine that I'm trying to get tomorrow. So I am sort of like interrupted by that thought a little bit. Okay. So the president of the condo sent a letter out to the tenants, right? And about the damage, about the issue that they have to renew the permit for the building, which is to be in the very next year, and then they need to conduct the serious repair. The damage, the serious ones, the more serious than a few years ago, was observed, and yes, it is significantly worse since the initial inspection, and that drove the cost, the estimates, to something around 16 million US dollars, from 9 to 16. Yeah, that's quite a jump. You can visually see the concrete falling or cracking. That means that the rebar holding it together is rusting and deteriorating beneath the surface. All right, yeah, that's the language of the, not the structural engineer. And yes, now they start thinking seriously about the repair of this building. And on June 24th, around 1:20 a.m. in the morning, which is the time that people are in bed, most of them. For those who stay up late, they can make it. Some of them can make it, but for those who slept already, yeah, there's quite no chance. So the structural member collapsed and occur in the underground level. Oh, this is just the warning, the triggering of the collapse. When this thing happen, it is just the alarm that drive the people out of the building. So those who heard the very loud member collapse sound in the underground level just run out of the building. They can feel the sway of the building. The building was described to be like flowing, swaying like the paper. But yeah, that is not the structural engineering language. It is so difficult to estimate how much sway we had over there. And 1:22, the partial building collapse occur. So yeah, some of these are the paper, the document, the circulations. This one is the letter in April 2021. So it said something about inspection required by law to cover life safety issue, blah blah blah, right? Okay, this was the estimate, initial estimate 9 millions. And okay, let's see. So this part comes out first, the middle part, and then this one lose the stability, and then yeah, the columns down here is gone. Come back here again. Okay, this piece come down, this one still stands, and then you can see that this part soft first, right, and bring the thing down. And if you come back again, you can see the dust coming up even before this part coming all the way down. The dust comes up here, right, and then this part comes down, and then the dust comes up from there, and then this one comes down, and then the dust comes up. So what happened? Something happened over here first, and then that triggers somewhere something there at the mid part to be the next thing, and this is the last thing, the closure. Okay, so let's finish this video and come to the next one. Oh no. This is another video was taken at here. I think you still remember this location where is the another entrance to come to the underground level. You can see water leakage out like this. They try to show the upper part of the building to show how they sway, but it cannot be seen clearly from the video footage like this. And this is the moment after the collapse. So it looks like this. You can see a lot of emergency response unit, literally 80 emergency units, 80 what, police, ambulance, and fire trucks. So the entire wing came down. Sorry. This is the video footage which is recorded inside the unit. So it's not suddenly coming down and boom. Okay, that's it. So this is the interview of the guy who brought his family out and survived. He can escape from the collapse.
When we first talked to Gabriel Neer just a few hours after disaster struck,
Me, my mom, my sister went out first collapse. We see the collapse happening on the pool side, and I saw a bunch of cars like going.
Oh, can you hear? Oh, sorry.
Going inside a car garage. So.
Oh, sorry. I'll bring you here. Okay.
when we first talked to Gabriel Neer just a few hours after disaster struck,
Me, my mom, my sister went out first collapse. We see the collapse happening on the pool side, and I saw a bunch of cars like going inside the car garage. So I panicked. My mom panicked. Everyone panicked.
we did not know where his first floor unit, 111, was in the building. Now we know it was here, just above the planter and underground garage entrance ramp that engineers years earlier singled out as the most serious flaw in the building. Proximity to that apparent failure point likely saved his and others' lives.
It was at that moment I saw the ground shaking. I felt like something was happening. At that time I had to run out, and I told my mom, my sister, everyone start running. And so that happened, everything starts to, out of nowhere, like cement of dust, sand like coming out.
The first signs of collapse appearing right at his unit. He estimates perhaps 2 minutes after he reacted to the thunderclap of a beam or column likely failing beneath his unit. While that may sound like a delayed collapse to a layman, engineer Jason Borden says it's an instant in engineering terms.
It sounds like an immediate or a spontaneous failure, which is unusual in a modern structure, which are built in with ductility, durability, and redundancy in mind.
Time for warning and escape are built into designs, but there wasn't much warning left here.
A freak accident, if you will, once in a lifetime for sure. I think possibly it was collective of things, deteriorations in the structure. So, but it's a very unfortunate, and this is the first time I've ever seen this in my industry, ever.
Andy.
Okay, we'll turn off the sound from the desktop. Okay, and come back here. So that's the interview of the survivor. And these are the pictures aftermath. I just give you these pictures. This is just the collections of the pictures that I have been searching from the news. Google app for all of these pictures and collect it from many angles. But initially, what we have, or what I have at the very beginning, there is no more information than just the collapse picture. But we, as the structural engineer, looking at these pictures, that's quite valuable. We can understand why this thing happened. We can understand the structural system. We understand what might be the failure point, what might triggers the whole things to come down. So let's see here. This is just the big angle, wide angle view. This is the hotel just nearby, hotel or something. I'm not sure about that, but the video footage we receive is from here, and then we shoot to here, this angle, right? Another angle is just before the collapse was taken from here. That's a tourist, and they shot the video into this direction. Another shot, you can see more clearly the swimming pool still there. This is not quite clear yet. You can see the entire wings was coming down to the ground. Another view. Yeah, this was a residence, a hotel of that tourist that you can see that they walks around here after the collapse and before the collapse. That lady was shooting the video to here, right? Probably they heard the sound already, so they just came visit to check what's going on. You can see this is the collapse. Well, this picture is not so clear yet, but the rubbles are just piling down to this direction, so it piles down to the front, to the beach. And this collapse also caused the main the building here. We can see that it gets some damage. It is not in the best conditions. And for those who live in this building, they were evacuated and they were never not allowed to come back in to take out their belongings off. Eventually this building was just destroyed, so they just demolished this building today in, well, somewhere around the daytime in Thailand for today, which is the nighttime in Florida. So they try to make it in the nighttime. And yeah, some more pictures. You can see emergency response units, a lot, literally a lot. You can see the ambulance, the fire trucks, ambulance, a bunch of these ambulance, but just a few of them get the opportunity to bring the patient to the hospital. Just a few, one or two people that they can just get out of the rubble, and the rest of them are still under here, under the rubble. Okay, but this is a very nice picture from where? Yeah, this is just the source of the picture, or AFP. Okay. This is taken from another view, so you see this part clearly, and the collapse part is there. Another view, and this is more close than before. If you have some good eagle eye, you will notice that this is the first floor level, and you can see here this entire slab just came down. It fell, it come down to the underground level, so these slabs are just piling on the car below. And you can see the fireman here and the levels there. This is not stable anymore. It is just ready to come down any moment, right? We do not see a lot of damage over here yet, but yeah, you can see some sort of imperfect condition, but it is more clear to be seen from that direction, if I'm not wrong. You can see the column, and these are two colors, two paints, the brown and the white, and it is not the column in one story to have to be painted in two colors, right? This is in the first floor, and this is in the underground level. The car just came down with the floor, and this is the clear punching shear failure. At the moment that I see the picture like this, I look around for the things, and here punching shear, punching shear, punching shear. So it is not just one location, it is several locations in this building. It says that it has something wrong in the design, especially for the slab itself. Over here, if you just look, you don't see anything, but if you look closely, these are column, 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 column. Column punch through the slab. Again, this is a very bad sign of punching shear failure, and this is the very first assumption and very first thing that come into my mind, that might trigger the failure of this structure. You can see the sinking into the underground level around here because the weight of the building that comes down and that breaks the slabs here. You cannot see the punching shear over here because you have too many things to that cover all the punching shear. Actually, this collapse site, the more picture one can take, the better, because when you come down to the office and look at these pictures just carefully, you'll be able to see many traces, many things that are leaving behind that tell us so much information about the building. All right. Further from this, I don't see anything more. This is the steel structure that locates basically at the rooftop before the collapse. The AC unit comes down. The brown thing, which looks like the asphalt treatment over it is the membrane asphalt. Okay, over the roof, come down here, and you can see the slab like the pancake. When I see all of these, seriously, I don't feel like the one who can make it, the one who can survive must be really lucky, because the structure just left no room for the survivor. If you see this picture, this pancake, well, what is going to be underneath? This building is made of the column and the flat plate. Flat plate means the slab without the beam. So it is good. It's save you the clear height of the building, because generally the beam is gonna take the space, and that is not good for the clear height. When you design, the architect may not like the beam, because when you walk, the clear height of your room will be controlled by the ceiling, and the ceiling must be underneath the beam. But when you have the slab system without the beam, then the clear height is not controlled by the beam, so you can be as close as the bottom of the slab as possible, just to minimize the construction cost. If the clear height is more, if you have more clear height, then you will have more walls, right? The wall will be higher. The higher wall, the taller wall it is, the more cost you have to pay. That's the fact. And yeah, on 25th, the day after the collapse, I look up for pictures as much as possible, and then I just got this one. And this one again tell me a lot about, first of all, we have this situation going on. We have the column standing alone without the floor slab. It happened here. It must have happened over here as well. What happened is the progressive collapse of the slab. When I showed you the video of the collapse moment, I point out something about the cloud, the dust cloud that comes up. I talk about the dust cloud that came up first in the area in front, I mean, if the camera is here, in front means somewhere here, right? So the dust pops up from this zone even before the falling down to the ground of this zone, right? So something must have happened before something over here in this zone. So it triggers from this area. Okay, close to the pool, there might be some sort of deteriorations. The tiling could trap the water underneath. It could be wet. It could cause the steel reinforcement to corrode. And when the steel corrode, you have the expansion. The expansion of the steel hurts the concrete because the concrete cannot withstand the tensile stress. Then it pops out as a piece. When it pops out too many pieces, that leads to the problem. What problem? Well, you have less cross section to withstand the load. So as the time goes, as the aging process continues, you have less and less and less cross section. So the capacity of the slab reduced continuously, slowly, but nobody noticed. Why is this? Why could this cause catastrophic collapse? The punching shear failure over here, the failure by the shear around the column head that punch through the slab is a sudden failure. It is the brittle failure. It is undesirable failure. Well, for those who are not the structural engineer may say that the failure is not favorable, of course, but the brittle failure is highly unfavorable because it happens suddenly. It gives us no sign. When it drops, when it fell, it just comes in and it shows no sign. So, yeah, the deterioration will probably be, well, again, the title of the presentation, I said precisely that I am talking about the possibility of the failure, of the root cause of this failure. The information I have, I just collect on the internet. I am not involving with any organization like ASCE or FEMA or National Institute of what, NIST, don't remember. NIST, yeah, probably, yeah. So I am not involved in any organization. I am not fed with the information. The information that I have is just from the pictures from the internet. I Google up and I got all this. So to the best of my knowledge, I collect all this information and assemble the jigsaw piece by piece. And then I came up with this possibility, quote in quote, all right, possibility. Well, 6 months later, 3 months later, if there could be some different conclusion, well, that could be. But from the video footage, from the pictures, from what I can see from the drawings, that leads to these possibilities. So I proposed my theory, let's call the theory. I proposed it on June 25th. Well, a few days later, I saw people, well, that is on the web board, chat board in the engineers in the USA, saying something in the same line. So it starts here, somewhere around here, not exactly here or there, but it is just in front. Front means this side of the building here. All right, column stick up, column stick up, column stick up, column stick up. This is the punching shear. This is also punching shear, and here also. Okay, so I circle, I highlight the area where the damage was from that day. Just another view and to see this clearly that the slab come down one level. This just tears off. The AC units are all here, yeah, and collapse. This is a very good picture taken from the fire rescue, Miami Fire Rescue, posted on Twitter. This is very valuable, and that supplements supports my claim regarding that speculation, that possibilities. You look at these columns, you don't see reinforcement sticking out, right? You don't see. This is just a plain bare column head. Look at this. You see just a few rebars coming out. This one slips off the slab, and the slabs around this column head just gets pulled up like this. You don't see even the cone shape, the incline, like 45-degree angle. This is very weak for a punching shear, and you clearly see only the top rebars. This is the slab. It is probably yeah, I should use the top of the slab is here, the bottom of the slab is here. The reinforcement here is the top rebars. You can hardly see the bottom rebar. Why? What is important about this? Because the code nowadays requires the engineers to put the bottom rebars in here, such that the bottom rebar will prevent the progressive collapse. You could have punching shear failure, fine. Well, it is bad enough, but still fine, as long as you have the progressive collapse prevention rebar, which is the bottom rebars. You'll be safe. You can evacuate people out of the area before the full collapse, but this gives you no chance. The slab just come down once the punching shear occur, and the punching shear occur before because the concrete deterioration, so it could be triggered somewhere. But when it is triggered, then one place, if this place is failed, the load will be transferred to the nearby column. So the load in this that is taken care of by this column will be transferred out, right, to the nearby column. And then that triggers the punching shear failure of the nearby column, such that the failure just spread out to everywhere. That is a problem, because the condition is no longer good. And then when the weakest link starts, when the weakest link fail, then it transfer it the engineering language is redistribute the load to the nearby column, and then they cannot withstand. Then that collapse just go progressively on and on and on and on. Wow. Now we come out of the big picture, the overview picture, and then we look at the structural system when the drawing is not available. But today a few days ago the drawing was available already. So well, fine. But just in case if the drawing is not available, every single picture, is going to give you some information. So this is the remaining part of the nearby building that survived. You can see this is the cantilever zone. You can see the top rebar around the column or the support like this. You can see this texture underneath the ceiling. What does this telling us? You can see this. The pattern looks like this, right? The strip line pattern. These are all from the pulling out of the bottom reinforcement. So the left side of the building comes down. The slab of the collapsed part pulls the bottom reinforcement, and then it gets just slipped off because the detailing of the rebar allows it to be just pulled off. You can see the reinforcement detailing a little later. But previously, before the collapse, you have the rebar inside, right? The bottom reinforcement. And when it fell down, it ripped off all these reinforcement and the concrete just show you the, how to say, the notch, the groove. Yeah, not the base word, but yeah, the groove along the line of the reinforcement. And we are so sure when we see this concrete slab, we do not see any post-tensioning strand, right? We can see only just the steel reinforcement, but no post-tensioning strand. So I know that this is just the flat plate. Well, how did I say that it is flat? Because, well, can I clear this? Sorry, this uncle is not knowing much about using this marker in the presentation. Well, display screen. Wow. Okay, erase all ink on it. Sorry. Okay, great. So where was I? All right. So look at this. Generally around the wall area, we expect to see the beam. If it is the structural frame system, the beam has to be here. But we can see no beam in here. It is clear. So it is just a flat plate structure. Flat plate without beam, without post tension. All right. What else that I can see? Well, the concrete strength is not that high from the color of concrete, right? But the quality is not bad. But it is so white, and to me, the strength will not be that high. We found later that the strength was somewhere around 227 MPa or somewhere around 270 KSC. So that is not it's just the ordinary strength concrete. But considering the time of construction, that's the base to use in that time. Another view, you can see this, right, very clearly. The reinforcement just gets ripped off. Okay, everywhere. Same for our floors. What else to see? This happens, the same thing happens, like this one here. The thickness is 9 inches. You just hit the calculator. What is 9 inches? This is from AP. Okay, we got to talk about the proper citation. What else? Let me see if I have anything else for you. They do not have the ceiling. They just use the bottom of the slab as a ceiling, and there is nothing to cover the bottom of the slab. Anything else? This must be from the wall, partitioning wall. And yeah, these are the slabs from the other floor. Partitioning wall, the aluminum framing. Yeah, no more. So we can continue. Another view. Yeah, nothing new. Another view. Piping. These must be like the electricity piping conduit. AC is coming down. This shaft could be the shaft. Yeah, the AHU must be coming out, or the ventilation something coming out. Yeah, that air duct. Well, a little more. The wall panel. This is just the light wall with maybe stucco coating on the outside, hollow in the inside. Here well, nice to see. The steel still holds up. The slab and concrete and steel together. No post-tensioning strand. Here, you can see the rebar gets ripped off from the bottom of the slab, but this cannot come out. Probably the development length is enough, or the detailing of this zone compared to another zone also could be a little different. So it is still stay there. Rebar. Okay, nothing more to talk in around about. Nothing more. The air duct, the slab that is hanging down. Here it is quite clear that the rebars, all of this gets ripped off from the floor. Well, look at that. So punching shear, this is get punched down as well. Punching shear, the bar comes down like this. I hope that this presentation is gonna give you a better the better feeling when you put the bottom rebar around the column, right? You will feel good about it. You will feel like, oh, I am saving life by having this rebar included in the drawing. This is just the top rebar. And I can get the structural drawing of this building, but I have quite many versions, and it's still like piling up in one file. Do not have much time. I have some other things to do. The client keeps calling every day, all day. These people want this, that people want that, all right? So that's just an excuse for me to say that I do not have time to dig into the very detailed capacity of each particular member. But okay, from what we see, we can see that it starts from the punching shear of the slab. And when we get the punching shear of the slab, what happens as the next? You used to have the constraint, okay, to this column on all four sides. The column is prevented against the lateral horizontal movement in X and Y. If we say that X and Y are the plane which is perpendicular, parallel to the Earth plane, Earth surface plane. So it gets prevented against this displacement. But when we have punching shear failure, first of all, I talk about the first floor columns that are quite slender already, right? At the very beginning, I showed you that the first floor is higher than the other floor. Well, that is just to make it grand. That is to make it luxury. Nobody likes the building that the first floor is just 2.5 meters. That looks just like cheap. But having the first floor higher than the other floor, that looks elegant. But in earthquake engineering, the earthquake engineer hate this situation because it makes us the soft story effect. That is the structural irregularity, which is not good in the behavior of the structure. But anyhow, it is unavoidable. So we need to analyze, we need to be very careful when we design the high-rise building, or well, even the low-rise building in the earthquake-prone area with the very high first floor. So we expect the top, the soft story and the irregularity. Well, but this is even worse. Why is it even worse? Worse because it used to be just that slender. So maybe another floor is up there. It used to be that slender. But now it is even more slender because the slab is gone. And as the slab is gone, you just have is there any like back? Okay, no back. I clear this drawing again. So it goes like, oh no, is it previous? Oh no, it's not good anymore. So this is 2 floor, and here is a second floor, and here is the first floor, right? And now we have the full story height. So from the second floor to the ground or the basement level, that makes this column taller than before. It could be like L1 and L0 like this, but now you have L1 plus L0, so it is somewhere around 1.5 times of L1, or more, maybe 1.7 times of L1. When we talk about the capacity of the column against the buckling, well, you have the stability problem now because you do not have the constraint, the restraining effects from the slab. So this, well, if you know something about the buckling, and if you have the E as the elastic modulus, the I as the cross-sectional second area moment of inertia, you have the buckling load equals to pi square EI over L square. But now EI is still maintained to be the same. You have the same cross-section. You cannot change the constant pi, but you will change the L square to be 1.5 to 1.7 L square. What does this mean? 1.5 L square is equals to 2.25 L square, right? 1.5 L and the whole thing square up is equals to 2.25 square. Too bad, this is the denominator. So if you used to have the capacity equals to P, right now you will have the P divided by 2.25. If you have 1.7, what do you have? 1.7 square, what is it? Something like 3, right? Because square root of 3 is 1.7. So P over 3. You have just half or 1/3 of the initial capacity. Well, the factor of safety might not be more, might not be enough to cover this severe reduction of the capacity. And consider the fact that wing, the beachfront wing of the condominium, they have the penthouse unit. The penthouse unit come at the last. It is the addition to the original construction or original drawing as far as I remember. Thus, it may not overstress the column, but the demand to capacity ratio is worse. Demand to capacity ratio tells us how close to the failure. If the demand divided by the capacity is equal to 1, that is the collapse point. So at the beachfront wing, we could have the demand to capacity which is close to 1.0. It could be like closer, well, let's say closer, but it will not be definitely close to 1.0 because the design was subjected to the factor of safety. But with the factor of safety, but when the capacity is reduced to 1/3 or 1/2 like this, it's not going to make it. And that explains also why that zone comes down to the first. Okay. So I clear this and come to the next slide. Okay, so this is the floor plan. Where is the mouse? The mouse, okay, it's not so clear. Okay, here's the floor plan. Here you can see, I think I need to get something like the arrow option visible. Okay, the floor plan like this. This is where the video was taken, and see the water leakage from the pipe, which is on around here between the L and M grid line. This is the entrance to the parking. Big foundation here, and that explains why just this part of the building come down, not the entire part to the left side, right? This is the pool. This is where we just saw the dog and the fire rescue person over here. The punching shear failure we spot over here, this zone. The pie actually might not be this one. There are many versions of the drawing, but just give you some idea. Yeah, this is the garage, parking garage floor plan, and this is what we spot at 1:18 to 1:20 a.m. June 24th. Water leaks out here, debris coming down around here. So there could be something, the collapse, the trigger that triggers the first collapse could be around this area, or even this area, because video that shots from here, we are not sure exactly where, if it is here or here, but around this grid line. This is the steel reinforcement layout of this building. This is just the floor flat slab. Well, there are some beams on the perimeters of the building, but when you just go up to the higher floor, you will not see any of this perimeter beam. You just find the flat plate. This is column. This is column. So you see the steel reinforcement in two directions. And this is between the grid line L and M. You can see that this is the ramp that the car come down. From the drawing, you can see the washroom. Washroom is here. Washroom is here. This is this is inside the unit, and this is in the recreation room. Okay, what's wrong with the washroom? If the washroom is around here, yeah, one thing it explains why the water pipe, the leakage was spotted, because the washroom are here. So if the floor around this area just fall down, we're gonna expect to see that water pipe leakage. And this is the pump room, generator room and washroom. It's not the residential unit, so it could come down first. This is the unit, apartment 111, that heard the very loud noise and felt the shaky floor and evacuated before the entire building came down. And yeah, the collapse might be around this zone first, so it fell down. It could be triggered by the area even below this grid line. Well, but then it propagates to here. Actually, I want to talk to that guy that ran out of the building, because what he saw is going to explain us a lot where exactly is the first collapse, because when he ran out, he must have seen some area that is already collapsed. But yes, he ran out of this unit, which is just right next to the video footage that was taken, and we saw the water leakage coming out of this strip. Yeah, this is a reinforcement. You can see I just give you the conversion, because most of us may not be familiar with the rebar size that are used in the USA, number 3, 4, 5. So equivalency is 0.5, 9 millimeters, 12 millimeters, and so on and so forth. This is the typical notes The floor slab thickness is 9 inches. 9 inches is 22 centimeters. At the basement, well, 9.5 at the lobby level, and the other floor is 8 inches. Sorry, so 8 inches is somewhere around 20 centimeters. It's not that thick, especially for the flat plate system. It's not thick at all. The post-tensioning slab for the span like 8 meters, 10 meters, somewhere around 25 centimeters to 30 centimeters. And that is the post-tensioning one. This one is not the active reinforcement. F prime C is 4000 psi, so I convert to you that 4000 is 27 MPa, so the 3000 will be, well, you can interpolate. You can get somewhere around 20, a little bit. Bottom reinforcement, number 4 at 13 inches, so that is what, 32 centimeters, right, in each direction. Reinforcement should be gathering around the column strip and so on, blah blah blah. Okay, I don't care much. Well, if anybody wants to get the building structural reinforcement, structural layout, and structural drawings, okay, you can ask for one from me. But here's the thing. Here's what I saw and later found in the structural drawing. You can see here, the bottom reinforcement is overlapped over 6 inches length. 6 inches length is what, 15 centimeters. 15 centimeters, the rebar is number, well, I don't remember, number 4. Number 4 is 12 millimeters. So if you have the lap splice and if you expect that the lap splice is going to transfer the full load to the yielding of the rebar, you will need probably 50 times, just the rule of thumb number, 50 times of the diameter, which is 60 centimeters. What you have here is 15, which is just a quarter of what is required to fully transfer the load. And that explains why, even though they have the bottom reinforcement, but it never worked in the it never worked as the progressive collapse prevention reinforcement. They have, but it's just not good enough. So when the punching shear occur, yes, the top reinforcement is going to carry the negative moment, but punching shear occur, there is no punching shear reinforcement at that time. There's no such thing. And well, I'm gonna talk about progressive collapse with the very nice picture later, but without the shear reinforcement and without good enough progressive collapse reinforcement, that's why we spot a lot of punching shear failure in the structure. And that is just the first triggering, because basically if punching shear failure occur, it is just one system, one floor. That's a problem to one floor, but too bad it occurs at the floor of which the height is the maximum, and then the height is multiplied by 2. The clear height turns out to be like 1.7 times, probably around that. So the drastic reduction was observed. The drastic reduction of the capacity occur, and then the next step is the collapse of the column. It lost the stability. It then fell down. Now this is the pictures that describe the effects of the progressive collapse prevention reinforcement. The left side is actually the same as the Surfside building. The collapse one, they have the top rebar. Bottom rebar they have, but they splice and that cannot develop the tension after the punching shear failure. So these two pieces of the slab fell down, leaving just this thing sticking out of the column, exactly the same as what we saw. But if you leave the bottom rebars in there, when it fell by punching shear, well, the top rebar will get ripped off. You can see when these slabs settling down, the top rebar just get ripped up this way. So we cannot rely on the top rebar. The top rebar will no longer useful after the punching shear, but the bottom one cannot be ripped off because it is hanging your concrete. So, well, you can have the cracking, you can have the breaking, but you do not have the collapse. Same, right? Same. You can see a little rebars, bottom rebars, but that is not going to hold. And some of them gets just pulled off already. This is also the part that is on the deck supporting the slab, deck slab. So you cannot see anything up here at the column top. It just it just fell out of place. And this is a clear shape of punching shear. It's just like pops up. The picture here is taken from ASCE, so it shows the evidence of punching shear failure in the real structure. But well, not bad, not too bad that this structure just have the localized failure over just one story. It's not bringing down the entire building. And this will be probably the last slide or last video. I didn't expect that my presentation will be like 1.5 hours. I thought that 15 minutes I'm gonna finish all of this up, but this is 1.5 hours. So okay, let me wrap this up by this video. This video was taken there, okay, at the mouth. It is the beachfront. Here is the avenue, I don't remember the name, right? This is the hotel that the tourists stay and take the video. 88th Street is just in between Champlain Tower South and that hotel. So this is taken, this is where the camera is. Okay, I just want you to know the collapse, the debris, the rubble is just on the back of the building. The thing is that the hurricane is approaching to Florida, and the rescue team are not so sure about the stability of the structure when it gets hit by the hurricane. We have no clue how it will collapse in the future when it gets hit by the hurricane. It is the uncontrolled kind of the collapse. So they collapse it before it is uncontrollably collapse by itself, right? And yeah, the residents in this area, in this wing, are not allowed to take out their belongings. Well, at least it is checked that if there is any pets remaining in the unit, they have the last check, but the remaining in here are not allowed. So nobody can just come in and salvage their belongings. So okay, let's start. By explosive charge, probably. No sound, too bad. Yeah, they manage to take down the front side of the building first because they do not want to make this the burden on top of the previous collapse. So they they pull the building to the road side, then the road has to be blocked before the demolitions, and yeah, this corner comes down first, such that it will pull the whole thing out to the road, to the public area. So just in case if there is anybody if anybody survive that collapse on the back, he or she will still survive. This one will not be just overlay on top of that rubbles. All right. my voice is almost gone. So thank you for your interest. I'm really sorry this is not the best presentation to my quality. I just give it like a B- or C+ to myself. I generally do better than this one, but this is just an informal one. I think if I spend too much time trying to make it perfect, then it will never happen. So yeah, and I'm very busy today with the vaccine and the other things. So this is just to the best of my capacity to compile the presentation to this point. If you have any question, you can leave it at the message comments in the live. I will as I record this video, so I will post this video on the YouTube a little later, and then I will post the link on this Facebook live. Thank you for your attention. So probably see you again in the FBminar number 3 that I do not know when, but I try to make it regular. Have a good night. Bye bye.